All right, here we go on chapter 2. The whole point of the Monty Hall problem is the fact that it feels like it should be 50-50. That seems to be common sense. We have that assumption and we're very confident in that assumption. The implication of that is that common knowledge assumptions, they're not always correct. We have to be very careful with what we consider to be common sense. And that's what science is all about. We're going to test what we might deem to be common sense and see if it's actually reality. So we're going to talk about, first of all, hindsight bias. So this is one of those phenomenons. We've all experienced it at some point in time. Something happens that's totally unexpected, but we have this feeling like we saw it coming, like we knew it was going to happen. Probably the most recent popular example is the 2016 election. Whether you liked him or not very many people thought that Donald Trump was actually going to win that election. However, once he won, there were a lot of pundits that got on the TV and said, oh, yeah, I saw that coming. No, you didn't. You never saw that coming. But there's this feeling inside of us that we look back and go, oh, yeah, I saw that coming. So that's hindsight bias. And we have to be careful of that. We have to be careful of confirmation bias, hindsight bias, overconfidence. We love patterns. We see patterns in different things, and then all of a sudden we think that there's some sort of correlation between those. It's not that they're necessarily wrong all the time. Maybe we can be very confident about a reality, but we want to test that out to make sure that our confidence isn't blinding us to some other reality. Okay, so you see there on the slide, it's all about having that scientific attitude. We want to be curious, skeptical, and humble. We're always curious about the world around us. You don't want to take things for granted. Skeptical. Again, you don't take things for granted. You have a skepticism about what we deem to be reality all the time. It's not necessarily an unhealthy skepticism. You're cynical, but you just are skeptical and you want to test things out. And humble. You have to be okay with being wrong when you're doing science. That's what science is all about, finding out what's right, what's wrong. And a lot of studies done recently on masks, and some studies have proven to be wrong early on, some of the early studies, and now all of a sudden they're realizing, oh, masks are more effective than we had originally thought. You wanted to be humble so that you can find out reality. And so we're going to look at some different types of studies. First of all, is a case study. So this is when you study one person in depth and hope to find some things that can broaden out to other folks. So let's say you know the oldest person in the world. You want to study the oldest person in the world. Great. So you find out all about the oldest person in the world. And one of the things that you find out about the oldest person in the world is that she happens to eat bacon every single day. Well, that anecdote doesn't prove anything. That doesn't tell us that we should all go out and eat bacon. That's availability bias. That's going to be an issue, obviously. Now, it can lead to further study. Do we want to look at her genetic makeup and see if there's a genetic marker that allows her to eat that bacon and process it differently than other people in the population do? Then we can start looking at other people in the population and see if they have that genetic marker. It leads to further study, but obviously with one person, you can't just generalize to an entire population. Naturalistic observation is when you go out into the wild, and when I say the wild, it can be a forest in Burma, or it can be downtown at a movie theater watching people in line at a movie. You're just recording behavior. You record what's going on, what people are doing, what that animal is doing. The book has the study about chimpanzees, and you just go and you watch. Now, that's going to describe behavior, but it's not going to explain behavior. One of the experiments that Mr. Woodard and I like to do when we're in the classroom is called the fidget study. And we'll talk about this throughout the PowerPoint. What the fidget study is, we'll take 3 people out in the hall. We give them a pen and a paper. We say, okay, we're going to go back into the room for 90 seconds. Everybody's going to be quiet. And all I want, back in the room, 90 seconds. I'm going to continue lecturing on the PowerPoint. What I want you to do is watch the class, and I want you to tally how many fidgets you see. Then we go in and we do it. Now, there's lots of other stuff wrong with that particular experiment. We'll talk about that later. The main point is, though, that those 3 people come in the room and they're doing a naturalistic observation. They're just watching for people fidgeting. Surveys are obviously very popular. We've all done a bajillion of them. And it's a good, quick way to get information. And you can get a lot of information from a lot of different people, especially with technology. One of the things with surveys right away, you have to worry about how the questions are worded. So they did a study once where they asked a group of people if they approved of government censorship. And you'll see there that you get 27% of respondents saying that's okay. Okay, so pretty low. Then they asked another group of people, well, do you approve of more restrictions on what is shown on television? You'll see that the number is much higher, 66% approved of it. It goes back to framing from the end of the last chapter. How we frame a survey question could determine how people are going to respond. So you have to be very careful with the way that you word a question. Obviously, those are the same thing. You also have to make sure that the population is randomly sampled. If I want to sample Washington State via a phone poll, I'm not going to just dial numbers that have a 509 area code. I have to randomly sample the entire state. It's one of the big issues right now with the election. They're wondering why the polls were so off, and they were off in 2016 as well. So people start asking, did we appropriately randomly sample the United States population? What other variables might have contributed to the fact that our polls were so different than the actual election results? Which brings us to the last big problem with surveys, is that people might not answer reliably. So, and we've all felt like this too. Even if we know a survey is completely anonymous, we have a tendency to be fearful of putting down something that's going to look bad if we have some sort of flaw. How often do you study for your tests? And you don't study but for about 10 minutes right before the test, but you don't really want to admit that. So you kind of fudge a little bit on that survey. So surveys are good resources for collecting a lot of information, but you always have to have that skepticism as far as the honesty of respondents. That's why when you do have those surveys in school, I know that they can be a pain sometimes, but super important to answer those responsibly. Okay, longitudinal studies. These are difficult, time-consuming, but they give us a ton of information, and that's because they are done over a long period of time. So you take a sample of the population and you study them at different intervals over a period of years. You have to keep track of those people, which is difficult. You have to come back to them every so often. Difficult, time-consuming, but it gives you a lot of really good information. There's a lot of stuff going on in that bullet. Here's the main point of that. You might do what's called a cross-sectional study, which I'll talk about real quick on the next slide. But a cross-sectional study is when you take kind of a snapshot at one place in time. Well, you find out that the poverty rate at a given point in time is 20%. Well, does that mean that 20% of the population is always poor? Or does the entire population experience poverty 20% of the time? We don't know that if we do just a cross-sectional study at one point in time. However, if we watch a group of people over 10, 20, 30, 40 years, then we can start to see the differences between that number of 20%. Okay, a couple of cool longitudinal things that we have linked here. The 56 Up trailer is a documentary, and they followed a group of people, and they talked to them, I believe, every 7 years. And by the time they're 56 is when they make this documentary. And then one of the famous longitudinal studies is a Harvard study. I think it wrapped up in 2017. It might still be going on. In 2017, though, they released an article that's linked here. And they actually have been watching people. By 2017, they have been watching the same group of Harvard students for 80 years. Fascinating stuff. We might be able to talk about that more in class. And then real quick, I know I've been talking for 9 minutes here. Cross-sectional studies. You sample groups at different points along a developmental path. So this is a little fill in the blank. Surveying the same people every 10 years is longitudinal. Surveying 20-year-olds, 30-year-olds, and 40-year-olds at the very same time is cross-sectional. That's when you're looking at 3 different groups, but you're looking at them at the exact same time, cross-sectional. And then cohort sequential is a combination of both of those. You look at those different groups, but you look at those different groups at point A, point B, point C, year 1, year 10, year 20, etc. Okay, I'm going to be quiet now. I'll give it over to Mr. Woodard so he can talk about correlational studies.